Before we dive into the practical part of C++ coding, we have to wrap our heads around the concepts first. It'll be difficult to go around using functions that we don't really understand. To cut short, basically C++ coding language is a general purpose programming language that is designed to, make programs, create software. If we're gonna go in the plethora of games that it is used on, there's Genshin Impact, Counter-Strike, Valorant, Pokemon Go, and even consoles such as Xbox, PlayStation, and Nintendo Switch. Let's talk about the 7 primitive data types of C++ coding language. So, when we're talking primitive, we actually mean that not because they're actually old or that they're decrepit or they're archaic, they're useless in this time. It just means that they are the basic or the fundamental data types that would make up the more complex ones. So the first one is integer or keyword int. This is used to represent integer data types, with the range being negative 2,147,483,648 to 2,147,483,647. This one takes about 4 bytes of memory. An example of integer data is 115, or basically anything that doesn't have decimals or exponentials. 2. We have character or the keyword char. Now, this ain't the char that we use to joke around or the char we want on our food. No, this char is a data type used to represent characters, and it only takes up about 1 byte of memory. And characters need to be enclosed in single quotes or single quotation marks. An example would be char, single quotation mark, V, and then close it off. Boolean. The keyword for Boolean data types is bool. It usually comes in the values of true or false and is particularly used for conditional statements and loops that we'll tackle later on. Oh, and they also take 1 byte of memory. So, an example would be bool is underscore true is equal to true. Next is floating point. Now, if you haven't noticed yet, the keywords are just stored in terms of the original names of the data types. For this one, we have float as its keyword. Now, this data type is used to hold decimals and exponents. Just like its brother, int, float takes up to 4 bytes of memory. So an example of this would be 36.5, 38.8, or anything that has decimals, even exponents like 2 squared. Double floating point. Now this one is just the upgraded version of float in terms of accuracy. This data type is used to store decimal and exponents with double precision using the keyword, can you guess? It's double. But of course, twice the purpose also gave it twice the size, taking up 8 bytes of memory. So an example of double values is equal to 2024.1029. Void or valueless. As the word itself, this is really nothing. Now, why do you have to make a term for nothing? It doesn't really make sense to me. But regardless, this is just coding and not a philosophy class. It is still needed for functions and not for returning any data. Wide character. Now, just like float, char has its own big brother too. Using the wchar underscore t as its keyword, it takes about 2 to 4 bytes of memory. It represents characters that a single char cannot express. For example, wchar underscore t x is equal to e single quotation and s single quotation. Another data type used in C++ is called string, which stores and uses words, characters that have several letters compared to char. The amount of bytes it consumes on a memory depends on the word that is used. It can be 1 byte for standard English characters, while it can take about up to 4 bytes for other non-English characters. Alright, that's about it for the data types for now. We don't really want to commit an MKUltra information overload. We will just stick to the basics, or rather the building blocks of it, right? For now, we'll head to the operators in the C++ coding language. And again, we'll take it easy. Now we have our basic arithmetic operations, and these operations can be used in building a calculator code, a transaction code, or anything with numbers that most of us cannot really comprehend. We have the plus sign for addition, the minus sign for subtraction, asterisk for multiplication, dash sign for division, and the modulus sign for, percent. Next up is the relational operations, which is used to compare values and return a Boolean result. This can be used in conjunction with the arithmetic operations. Say, for example, on the age confirmation code, or your grade, whether you got that sweet President Lister's mark, or you'll take another year in college, or something that, may give you feedback in general. Alright, here are the examples on the screen. Say, for example, equal to has two equal signs beside one another. Is not equal to, exclamation mark, and an equal sign next to it. Greater than, less than or equal to, and greater than or equal to. So these relational operations are usually seen or used in codes that have conditional statements. With that being said, we'll be heading to our next topic, conditional and loops. Conditionals are usually enclosed by curly brackets. As its name suggests, it has conditions for the program to run and happen. First up, if statement. This statement executes a block of code if a condition is met, or in coding terms, true. If the condition is met, it will run the code. If not, it will go past that said code. So here's a flow chart for better comprehension on how the if statement works. The syntax for the if statement goes like this. Add the single line or multiple line comment, then if, and within the parenthesis is the conditional statement, then use the curly brackets, and then enter the code to be executed, and then curly brackets, and then the code after the if statement. Number 2, we have if-else statement. Now this statement runs just like the if statement, only with a minor change. If the code within the if statement is true, then the code within that block gets executed. But if the code in the if statement is false, then it would be the else statement's code that will be executed. This is the syntax for the if-else statement. So, if, then enter the conditional statement in the parenthesis, then curly bracket, the code to execute the conditional statement if it is true, and then curly bracket, and then else, curly bracket, then the code to execute when the conditional statement is false, and then curly bracket. Here's an example of if-else statement with a sample code of age confirmation. So include iOS stream, which is input-output stream, so everything below would work. Int main, curly bracket, int age, stdc out, enter your age, stdc in, this is where you would enter your actual age, and then if age is greater than or equal to 18, curly bracket, stdc out, you are eligible to vote, stdndl. So that would be the output that would show if you are greater than or equal to 18 years old. And then the else statement would be stdc out. If you're not 18, you are not eligible to vote. That will be the output. And then return to 0. Now, as we can see in the if statement code block, the condition is the age should be greater or equal to 18 in order for the cout statement to be executed. When it comes to else, if the person entered an age or value lower than 18, then they are not viewed as eligible to vote.